In this video we will look at the sine rule, and with the sine rule we tend to use this when we have non-right angle triangles to work with. And so as I do this, I am currently drawing a non-right angle triangle and just labeling my sides. As you can see from what I'm doing is that we're going to have the opposite angle there that goes with the side. So big A means an angle A, side A, angle B, side B, angle C, and side C, and so on. Now we can prove this rule but using the area of a triangle, but for now we'll just jump straight into it. The sine rule states that little a, or side A, divided by angle A is equal to side B divided by angle B, which is equal to side C divided by sine angle C. It's also important to note when we use the sine rule. So we use the sine rule under certain conditions, which I will just jot down here. So for example, first of all, you use the sine rule if you were given two sides and an angle opposite one of the sides. You also use the sine rule if you are given two angles. So two angles and a side opposite one of the angles. So these are some of the conditions in which we will use the sine rule. Another thing to point out is that you'll only ever be using two parts of the sine rule depending on what you've been given. So let's take this out for a quick road test and see what the sine rule looks like. So we have a lovely quick and easy question to get us started, and let's have a look at what we've been given. So we've got a non-right angle triangle here. We've got one side given and an angle opposite that side. We have a side that we need to find and another angle. So this obeys the rule that we've got two angles and a side opposite one of the angles. So therefore we will use the sine rule. It fits the criteria, so let's go. We'll only state the two parts that we really need here. So we're going to say a over sine of 46 is equal to 11 over sine of 79. For this you're going to need a scientific calculator, and please make sure that it is in degree mode because we're working in degrees. Now if you've got, I don't know, there are various ways that you can go about this, but I think I'll pretty much go straight for just solving it quickest way possible. I've got a fraction on either side of an equal sign. I need to find a. This sine 46 needs to go. It's currently dividing by the a, so in order to get rid of it, I will multiply by sine 46. I'm just going to say that I'm multiplying by sine of 46. When I multiply by sine of 46, a will now be on its own, and then I'll get 11 sine 46 divided by that sine of 79. So what I've done, I've sort of cut a few corners there, but what I've actually done was multiplied by sine of 46 here, I'll multiply by sine of 46 on that side over there, and then what ended up happening is that cancels that out, leaving me with just the a on its own. And then this multiplies by 11, giving me that there. All right, a quick job in the calculator now to give us an answer of 8.1 or 8.06. Let's leave it to three significant figures, 8.06 centimeters. And that is pretty much done. That's the sine rule used and done. Let's have a go at another question. All right, so this is another question that we're going to look at and see it fits the first criteria that I spoke about when you talk about the sine rule. I've been given two sides and I've been given an angle opposite to one of the sides. So that's 32 degrees there. I need to find this angle here. Just for the sake of uniformity, I am going to put this as a big capital A rather than the little a in there, okay? So just for the sake of uniformity. All right, so let's state our sine rule. It's always going to be the opposite side over sine of the angle. So what we've got here is that side 8 over sine that angle, and then I'm going to do 6 over sine 32. So that is equal to 6 over sine of 32 degrees, which is the angle there. And just as I've said before, so we will end up cross multiplying here. Now, I don't know, there's so many ways we can go about this. Right, so let's just cross multiply from this point onwards here. So just to show you what I'm going to do. Cross multiplying means that I can multiply there and there on opposite sides of the equal sign. So what that gives me is 8 times sine 32, which I will write here. 8 sine 32 is equal to 6 times sine A. So I will just jot that here, 6 sine A. Bearing in mind, I need to know what A is, so I need to find out how I need to make that the subject. So now I'm going to move this 6 because it's multiplying by sine A. So I will divide by 6 to get rid of it. So this then gives me 8 sine 32 over 6 is equal to sine A. For those people who needed to see the steps, when I chose to divide by 6 at this point, I'm dividing by 6 like that, both sides by 6. And then what happens is that 6 and that 6 cancels out, leaving me with just sine A. And then everything here on the left-hand side stays the same. Okay, good. Now, what I'll do is I need to find what A is. So I need to remove that sign there. And for this, we need to do the inverse sign, if you remember from the videos on our trig ratios when you're finding an angle. So therefore, that gives me sine inverse of 8 sine 32 all over 6 equals to A. This I'll just plug in my calculator and then I'm done. All right, so that gives me an answer of 45 degrees, actually 44.95. So I just decided to round that up. And that's what that angle turns out to be. All right. Right, I thought before I finished the video, because I've basically explained everything I needed to explain to you about the sine rule, I thought before I finish the video, we should probably look at a problem-solving question. So I'll read out the bits of information that you need to know about the problem-solving question. It says here, in the diagram, ABC is a straight line. So this is a straight line here. That's important to know because that will help us out later, especially if we need to find that angle there. It says calculate the length of BD. So this is BD here. Calculate the length of BD. So let's go ahead and do that first. If we consider in the triangle BCD, that's the triangle we're working from. This is good practice if you're doing this as an exam question. Tell the examiner where you're working from. So I'm going to tell you now, I'm working inside of triangle BCD. And inside that triangle BCD, what do I know? I've been given two angles and I've been given a side opposite one of the angles. And I need to find that side that is opposite that angle. So that says to me, two angles and a side opposite one. That says I need to use the sine rule. So I will start with 12 divided by sine of 65. Don't forget, as I keep stressing in this video, that it is the side opposite sine the angle. And that equals to this side we need to find, which I'll call BD over sine 47. So BD over sine 47. Now we do a quick bit of rearranging. What I'll do is I will just literally move that sine 47 and then BD will be on its own. So I'll just multiply by sine 47. So I'm going to just put a little bit of working out down, not a lot. Multiply by sine 47, multiply by sine 47, and then that will then give us 12 sine 47 over sine 65 is equal to BD. Now I want to point out here, I probably should have pointed this out earlier in the video. Some people make the mistake of doing this, sine 47 times 12. Don't ever do that, ever at all, because your calculator will interpret that as multiply 12 and 47 and then sine it. So try not to do that because that's not really appropriate. Okay, I always like putting it on that side so that you know you don't get it mixed up with what you're doing. Okay, all right, good. So that's fine. Let's rub that out. So that's just a one of our don't do that ever. Okay, plug this in the calculator. Right, that works out to be 9.7, so we'll just put that down as 9.7 centimeters is BD. Okay, so that's fine. That works out BD for us. Let's carry on with the problem. That's just part A done. In part B, calculate the size of angle DAB. So I'll probably just jot that down over here. So that's B now. Calculate the size of angle BAD. Now, to find the size of angle BAD, we need to find the angle at A. Let's trace it. BAD. So we need to find just this angle inside here. That angle is unknown. Right, let's see what we've got. Well, we've actually just calculated the length of this side, haven't we? So that length of that side is worked out to be 9.7. And let's see what we've got now to see what we're going to use. If we consider that we're using this triangle ABD, we know two sides, and we know we need to find that angle here. But I also want to say we also know this angle, which is opposite that side. In case you ask me how we know that angle, well, remember at the beginning of the question I said to you that this is a straight line, ABC. That's where that comes in now, because in order to find this angle here, I know that it's on a straight line. Angles on a straight line add up to 180 degrees, which means that that has to be 115 degrees, which I'm just going to jot down here. So 115 degrees. Just take it away from 180. All right. So tell the person who's marking this that you're working in triangle ABD. And what you already know is you're going to use the sine rule. So we've got 12.9 over sine 115 is equal to 9.7 over sine the missing angle that we're looking for. So if we point that out there again, we know two sides and an angle opposite one of the sides. That's the angle 115 there. So this is now easy to work out. Feel free, if you want to, pause the video and see if you can work it towards the end without waiting to see me work it out. All right. Okay, I'm just going to go straight ahead and cross multiply. If you haven't paused the video yet, you should have done so. Cross multiply there, which will then give us, once we rearrange that, that gives us, let's put it on this side over here, 9.7 sine 115 is equal to 12.9 sine the missing angle theta that we're looking for. And then now, because we just want the angle, we will get rid of that 12.9 by dividing by 12.9. So then that gives us 9.7 sine 115 divided by 12.9 is equal to sine of the missing angle. Okay, so what we'll end up doing now is, like I shown you before, since we need to find that angle, we will now end up just removing the sine and sine inverse everything on that side over there. So let's just move this up so we can get some space, and here we go. So this then gives us, I'll just carry on working on that side over here. So theta is equal to sine inverse of 9.7 sine 115 divided by 12.9, and pump that in your calculator, which works out to be 43 degrees. So that's going to be 43 degrees there. And that is our answer, because they've asked us in this particular question to go ahead and work out this angle BAD, so the angle at A, BAD, that's the angle, and that angle is 43 degrees. The last part of the question is calculate the length AC. So let's have a quick look at what that is they're asking us to do. Calculate the length AC. The length from A to C is this whole length going across here. All right. I already know that A to B works out to be 5.4. Well, not works out, they've given us that. I need to find this length BC, which I can then add to 5.4 to then solve my problem. Now, because this video is about sine rule, I will force us to carry on working with the sine rule, and then we'll see where we're at. Now, what I want you to consider here is look at what we already know. From the whole triangle, there's so many ways we can go about this, so many ways. But anyway, I'm going to stick to this that we're doing now. If we look at the whole triangle, just ignore this bit in the middle here now. We know that side, which is opposite that angle. We can find the angle at the top here and then do this whole side here. We probably don't even need to think about at 5.4. We can do this whole side here opposite that angle. Or you can work with this little triangle here and just do this opposite that angle in here and one of these opposite the angles that correspond with it. So it's so many ways. For today, I think what I might do is stick with a little triangle. Yeah, I'll stick with BCD. I'll first of all find that angle at the top there. So let's get cracking. All right, so let's finish this quicker now. So I've redrawn the triangle so that just to refocus you on what we're doing. We're going to find this missing angle up here first of all by doing just a quick bit of calculation. We know that all the angles in a triangle add up to 180. So if we do 180 take away that 65 and 47, we get 68. So this angle here is 68, which is good. We're going to use our sine rule again to now say, in order to find this missing side here, BC, we will do BC over sine of 68 is equal to 12 over sine of 65. We'll do a quick rearranging. Obviously, I'm not hanging about this time because video is getting too long now. Over sine of 65. That then equals to 12.3. So now that I know that this side is, oopsie, wrote the wrong thing. Now that I know that that side is 12.3, I can now say that the length of the side AC, let's remind ourselves real quick as to what we're looking for. If we pop back up here, this side is 12.3. So the length of AC from there to there will be just adding that 5.4 to it, giving us 17.7. So I'll just pop that down at the bottom here to say, to final answer the question, therefore AC is equal to 5.4 plus 12.3, which is 17.7 centimeters. And that's it done. So that's just a quick problem solving question just to show you how you can use the sine rule to get everything into perspective, and that's our whole question there. Hope you enjoyed this video. Hope you learned a lot about the sine rule. Check out the other video now on cosine rule because that will use some different rules to get you going.